Okay, in the last video I have told you that I will tell about the exact equations, and this we have concern with this equation. M is a function of xy into dx plus n is a function of xy into dy equals to 0, and this is if this is homogeneous, then we take the substitution process and then we solve it in the same manner. So but if it is not homogeneous, then we move forward and we check that whether it is exact or not. And I have told you the exactness criteria for this is you have to take m of xy and you have to differentiate partially with respect to y, right? And you have to take n and you have to partially differentiate this function with respect to x, and if it is common, in both sides are common, then this is an exact equation. This equation is an exact equation. Now method of solution is we have two different methods. First method, we have to start with m and we reach to n, and alternative method is that we have to start from n of xy and then we reach up to mxy. I told you in the last lecture that the basic purpose for this for solving this type of equation is to get the solution. So this is the implicit type of functions. So the solution is also in the type of implicit, and that is f of xy equals to c. So our objective is to find out the equation or solution in this form, f of xy equals to some constant. Okay, the procedure, I will tell you the first procedure. First procedure is that you have to assume point number one is assume m xy partial f by partial x. Let m is equal to partial f by partial x. So I told you our objective is to find the solution f of xy. So if you want to find f of xy from this assumption, what you have to do, you have to integrate it with x, right? So integrate this equation with respect to x. So this is also partial derivative. So if you integrate this with respect to x, I am writing this right hand side in this left hand side, right? So if you integrate this function with respect to x, one is derivative, one is integral, it cancels each other and we get the function only f of xy, right? And I am writing this left hand side in this right hand side. So if you integrate, because we don't know the specific function, right? So we write it as it is like this, m of xy, and we are integrating it with respect to x. Now one thing I have told you in the definition of ODEs and PDEs, first is with respect to single independent variable or with respect to multiple independent variable respectively. This is the main difference, but there is a difference in the solution of these two, ODE and PDE. Now we are dealing with PDEs, and I told you in ODE the solution is of the type, the solution contains arbitrary constants, right? And in the PDE I've told you the solution contains the arbitrary functions. So if we are integrating partial derivatives with respect to x. Now here y is a constant, right? So we add the constant of integration as a function of y, and if we have the partial derivatives in terms of y and we are integrating this type of function with respect to y, right? So here x is a constant, and what you have to do, you just have to add the constant of integration in terms of x. So we are adding, because we are integrating this function with respect to x. So here y is constant, so I am adding the constant of integration as h of y or g of y or something like that. So this is the function. We mention this equation as a, right? So this is the step. Now we have to relate this m with this n. So next step is we have to assume, here we have assumed that m of x y equals to partial f by partial x, and in third step we have to assume that n x y is equal to partial f by partial y, right? So what you have to do now, we have to relate this equation with this equation. So we can write it, that step is a very technical step, right? So nxy is equal to, this is partial derivative with respect to y, so we can write is partial by partial y, and here is f is f of xy, so we can write it like this, f of xy. So f of xy is here mentioned in this equation a. So what I'm going to do, I am just replacing the equation a, that is f of xy. So that becomes partial by partial y integral m xy dx plus h of y. So I don't have any specific function, so what I'm going to do, I am writing it as I'm writing it like this, integral m xy dx, and h is only the function of y, and if we differentiate it with respect to y, so it becomes h dash of y. Here partial derivatives becomes ordinary derivative because it is only the function of y, right? And then most of the terms cancel each other in the left hand side and right hand side, and we only get the function of y. And in the last step, step number 4, we are left with only the function of y, and here is h dash of y, right? So what we are going to do, I told you that in this left hand side we are left with only the function of y, so now we can integrate it with respect to y, and then we get the solution in the form of f of xy equals to c. And if we do the specific examples, then it will be definitely clear to you, right? So I am in the next video I am doing one example of this exact equations. I hope that you understand this procedure.